everyone, it's Alyssa and welcome to You Can Learn Math. Today is about simplifying square roots. How do we simplify a square root? Just as a quick little thing, what is a square root? If I say the square root of 9, what am I asking? I am saying I want a number that when I multiply it times itself, it equals 9. So in this case, 3 times 3. 3 is the square root of 9 because 3 times itself, or 3 squared, equals 9. As you might guess, squared, square root are opposites of each other. It's okay, that's all well and good. And you're like, yeah, I've done that before. What are you going on about? What's different? Here's what's different. We're talking about when you have something like this. What is the square root of 75? Okay, now they do not want you in this case to type in square root 75 on your calculator, enter, and write that number. No, your answer is either going to be just a plain number, like 6 or 7 or 25 million, or it's going to have a radical, that's what this is called, a radical left in it, like 6 square root of 2. Or 3 square root of 7. It may look like that. That is considered simplified. When what you want is you want whatever's under the radical to have no perfect squares in it. A perfect square is something like 4, which is 2 squared, or 9, which is 3 squared, 16, 4 squared, and so on and so on and so on. So the question is, how do we get rid of those perfect squares from under the radical? Well, here's something that's important to know. And I'm going to show you with an example here. If I said square root of 16, you might say, okay, square root of 16 is 4, because 4 times 4 is 16. And you could write it like this. Square root of 16 is 4 times 4. So you go, okay, that's 4. Well, there's also another way you could write it once you got to this point. Once you got to the point where it says square root of 4 times 4, you can actually separate it. Square root of 4 is 2. Square root of 4 is 2. 2 times 2 is 4. And it's this property that we're going to use, that you can take a square root and divide it up. As we're talking multiplying, not adding. This is key. Right, so when you're looking at these, you're going to be trying to find a perfect square inside it, a factor of 75 that is a perfect square. Now me, I look at it and go, what are my perfect squares? 4, that doesn't go into 75. 9, no. 16, no. 25, hey, 5 squared is 25. 25 goes into 75. So this is 25 times 3, or square root of 25 times square root of 3. Square root of 25 is 5. 5 square root of 3, or 5 times the square root of 3. And there, that's it. We've simplified it. The big thing with this is when you have things like this square root of 75, where you're trying to figure out, what the perfect squares are. And sometimes they're going to give you things that are pretty big, like say square root of 180. Now maybe, you look at that and you go, ooh, 18, 9 times 2 is 18, and 9's a perfect square. Okay, I'm on my way. If you can do that, that's great. You may have to do a factor tree. I'm going to show you both ways. So let's say you looked at 180, and like I said, you went, oh wait, 9 goes into 18 2 times, so 180 is, say 9 times 2 is 18. So 9 times 20 must be 180. Okay, cool. 9's a perfect square. Woohoo! So you go, all right, this is the square root of 9 times 20, So square root of 9 times square root of 20. 3 times square root of 20. Yay, I'm done. No, you're not. It's always, always, always a good idea, even after you pull out one square, to see if there's any left. What is 20 equal to? 20 we could say is 2 times 10. Of course, 1 times 20. 2 times 10 and also 4 times 5. Hey, 4, that's a perfect square. So square root of 20 is square root of 4, zoom out, scoot this up, times 5. Still got our 3, haven't forgotten about it. So square root of 4 times square root of 5. 3 times square root of 4 is 2. Square root of 5. 3 times 2 is 6 times the square root of 5. Because 180 is equal to 36 times 5. So the square root of 180 is the square root of 36 times 5. You can see where this is going. 36 square rooted is 6, square root of 5. Okay, so that's a method we can use. Like if you can see, without doing anything, you can see the perfect square inside there, whether you saw that it was 9 or whether you saw a 4 or whether you saw a 36. And you can eliminate it that way. And again, even if you don't get the biggest perfect square, in this case 36, on the first pass, it's okay. Just always double check. Like you see over here, like when you get to that 20, double check and make sure there's no more perfect squares in there. So, okay, so that's the one method. Well, what if you look at this and you see this 180 and you just don't see anything? Like I just don't see it. What goes into 180 that's a perfect square? This is where you can use factor trees. And I have a video that goes into a little more detail on factor trees. And I'll put a link in the description below. But let's do a factor tree for this one real quick. So, okay, 2 times 90, 2 times 45, 5 times 9, 3 times 3. Again, if that's totally confusing, please check out the description below for the factor tree video. Okay, and when I look at this, I'm looking for pairs. So, there's 2 2s and there are 2 3s. So I can say this is 2 times 2, 3 times 3, and 5. Because that's the only one left over is 5. So the square root of 2 times 2 is 2. The square root of 3 times 3 is 3. And then square root of 5 just stays the same. 2 times 3 is 6. 6 square root of 5. If factor trees are easy for you, then this is probably the way to go. Now, what if we add in variables into this equation? Then what do we do? What if it's something like square root of a cubed? Well, think about this. What is a cubed? It's a times a times a. Well, a times a, that's a perfect square. So this is the same as square root of a times a, or a squared, times a. Square root of a squared is a square root of a. Move this over. Okay. I'll do another one. See if you can see the pattern that's going to emerge here. What if it was a to the power of 6? Well, a to the power of 6, a times a times a times a times a times a. I've got 3 a's times 3 a's, or a cubed times a cubed. The square root of anything times itself, like square root of 50 times 50 is 50. The square root of 93 times 93 is 93. The square root of a to the 10th times a to the 10th is a to the 10th. Okay, this is a pattern that you need to be aware of. So the square root of a cubed times a cubed is a cubed. Okay. So what the pattern that's happening here, and hopefully you're starting to see this, is these examples. Like here, square root of a to the 6th, a cubed. What happened there? Divided by 2. This was an even number, divide by 2, and I get my square root. What happens over here? A cubed. A cubed is not even. It is, that 3 is not even. It's odd. So what happens? I have a squared. I have a leftover a. 2 divided by 1, just get a to the first, and a leftover a. That's the pattern. So like square root of a to the 5th, 5 is odd. So I'm going to say square root of a to the 4th, and that leftover a. For this one, I divide it by 2, a squared, square root of a. Okay, so let's say something like, combining what we've done previously, square root of 75 x to the 4th, y to the 5th. This is just a combo of everything we were doing. So we look at it piece by piece. First, square root of 75. And I'm just going to write everything out. 75, I do my little process. I go, what's the biggest perfect square that goes into 75? 4, no. 9, no. 16, no. 25, no. Oh, sorry, 25, yes. 25, yes. Yes. And again, if I couldn't do that in my head, then I could just do a little factor tree over here. Okay, divide by 5 or divide by 3, either one. Go, oh, 25. That's 5 times 5. Hey, there's my pair. Doesn't matter which way you do it. You will still get the same answer in the end. Okay, so 75 is 25 times 3. X to the 4th is even, so it's x squared times x squared. Y to the 5th is not even. And actually, I'm just going to leave it as x to the 4th because we're talking about the even number. So I'm just going to leave it as x to the 4th. Y to the 5th is not even, so I'm going to change that to y to the 4th times y. Okay, so now there's certain things I can take the square root of. I can take the square root of 25. Square root of 25 is 5. And underneath my radical, the 3 gets left behind, taking care of those two. Square root of x to the 4th, I just divide it by 2, x squared. There's no other x's, that's gone. Square root of y to the 4th, y squared. Well, 1y left behind under the radical. And you're done. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.